So the setup for this experiment is pretty simple. This is me on my younger stepsister's scooter. I'll be moving at a consistent pace inside, and then I will be holding a ping pong ball in which I drop and try to make into the cup while I'm still moving, and then through that we'll be able to calculate time and velocity. Great stuff. So to begin on the calculations, we need to find a starting piece of information. So that can be found using Vernier video analysis, where by using a reference object and knowing the pre-existing measure of it, we were able to find the height of which the ball was dropped. So the scooter height, which is roughly 3 inches, and then the cup height, which is roughly 4. So 4 minus 3 is obviously 1, and then plus 4'10", which is roughly the height of my shoulder from which it was dropped from, ends up equaling 1.5 meters. So now we have the height of the object. And then as for the distance to the cup, same thing, using a reference on Vernier video analysis, we were able to find that the distance to the cup is roughly 0.4 meters. So now for the kinematic equations, here's a little diagram of what we're talking about. So here you have me on the scooter holding out the ping pong ball, and then the distance being 0.4 meters, the vertical drop being 1.5 meters, and then the ball should, in theory, follow this parabola into the cup. Now, the first thing that we can calculate from this is the time that it takes to fall. So here we set up the equation delta x equals v naught times t plus 1/2 at squared. Because there's no v naught as for the vertical velocity, we can cancel that out completely. So we're left with 1.5, which again is the vertical distance in which it falls, time equals 1/2 9.8, which is just the acceleration of gravity, times t squared. Now, you plug that into a calculator, you do it, you end up with time equaling 0.55 seconds for the ball to fall from the time the ball leaves my hand and falls into the cup. Now, next we have to find the velocity of the ping pong ball. So we start by breaking this up into finding v of x and v of y. No trig is needed in this just because it's a horizontal drop. So because we already know the distance and the time that it takes, we can put 0.4 meters over 0.553, which is, again, the seconds. It's just more specific than here. And that will leave us with 0.723 meters per second in the x direction. And then for v of y, we have 9.8, which, again, is the acceleration, times 0.55, which tells us, again, the vertical velocity, which would end up being 5.39 meters per second. Now, we have to find the end velocity in total. So here we can see if we, again, set it up as a triangle as we did up here, we actually get left with a right triangle, which sets us up to use Pythagorean theorem in order to find the hypotenuse, or in this case, the final velocity. So just doing that, we have v squared equals 0.723 squared plus 3.9 squared, which is going to equal 5.4 meters per second. So the ball, as it hit the cup, was going 5.4 meters per second and took roughly 0.55 seconds to get there.